Okay, welcome back to Physical Science Online Notes. This should be a fairly quick one today. Very straightforward concept. If you remember back to kinetic molecular theory, when we were talking about the phases of matter and how atoms move around in constant linear motion, that's going to directly link up to today's concept. One concept. We're going to look at it in a couple ways, but it is one concept. Just like all of states of matter, I said, could break down to kinetic molecular theory. Well, all of our chemical reaction rates can break down to collision theory. And I'll briefly describe that in today's notes. So first, you need to know what collision theory is then. It's there on your screen. Collision theory basically just says that for a reaction to occur, the reactants, so anything that would go through a chemical reaction, must collide. So they must actually come together. They can't be on opposite sides of the planet with enough energy and or in the correct position. So they can't just hit each other. They also have to hit each other with enough energy to transfer or combine or whatever they're going to do. Or they have to hit with the correct orientation, kind of like a lock and key type scenario. So that's what collision theory says. And we can use this kinetic molecular theory and collision theory together to try to increase the likelihood of this happening. So that's what we're focusing on today. Let me give you an example. I did this simulator in class, but I just want to do it in notes too to make this kind of sink in a little bit more. Is if we fire two things that should react together. So I do it with, let's do it with a little bit of energy first. If I just do a little bit of energy, then they will collide, but they might not react. There might not be a reaction there because there's not enough energy, even though there's two things in there that should react. But if we reset, there we go, and fire it with enough energy, so I fire it with maximum energy, so they're going to collide and they're going to react. There's that transfer or reaction that occurs. And if they collide again, they're going to react again. So this is a reversible reaction. Not all reactions are reversible, but if you collide with enough energy, they're going to react. But when they're away from each other, there's no way for them to react. If I let this simulation run for a little bit, eventually these things get a little off kilter. The system, I think, doesn't like this straight up and down motion. But that kind of shows my point here. They need to collide and they need to have enough energy. So then how can we create a scenario that would increase the likelihood of that happening if we want to increase the reaction rate? Or if we wanted to decrease the reaction rate, how could we lower that? Well, those are our factors affecting rate of reaction. I had all 5 of these factors on our notes last time. This time I'm just going to explain them from the perspective of collision theory and how that works. So particle size. We talked about this during demo day. If you have smaller particles, the reaction can happen faster. That's because there's more surface area. If you cut something, I used the block of cheese analogy in class, cut the block of cheese in half and you exposed more of the middle. There's simply more of it. Instead of it being in one big chunk, there's more little chunks, and so there's more collisions that can happen. Higher temperatures. Higher temperatures, we did temperatures during states of matter and kinetic theory. Temperature is a measure of movement. So if we increase the temperature, then the things are moving around more and they're randomly going to hit more often. So if we increase temperature, we can increase reaction rate. All of these examples are ones that increase reaction rate. Of course, you would do the opposite to decrease the reaction rate. So if I decrease the temperature, particles are moving slower and they're not as likely to hit. Number 3, increase the concentration. So you're just adding more of it. You're adding more of that solution. And of course, that will increase the number of reactions. Adding a catalyst. Catalyst is the toughest one. We're not going to go into details of what a catalyst is, other than to say that it helps them hit with the right orientation. Helps them get hit with the right orientation. And stirring. Stirring is when you actually add motion yourself by stirring or mixing it. And that, of course, will add to more collisions.